Have you ever wondered where it all began? How did the universe as we know it spring into existence? You may think the story starts with the Big Bang, but the true origins of Genesis are far older than that. Join us on this fascinating journey as we uncover the cosmic history leading up to the creation of the universe and how ancient philosophies and cutting-edge science weave together an incredible tale. Buckle up, this is going to challenge everything you thought you knew. The Big Bang is often hailed as the beginning of time and space, but what existed before it? Scientists have been grappling with this question for decades. Some theories suggest an eternal universe, oscillating between cycles of expansion and contraction. Others propose a multiverse where countless universes are constantly forming and dissolving, like bubbles in a cosmic ocean. Ancient texts from different cultures also hint at a timeless void preceding creation. In Hindu cosmology, for instance, the universe is periodically created and destroyed in a cycle of kalpas. These ancient insights surprisingly align with modern scientific theories like the ekpyrotic model, which suggests the Big Bang resulted from the collision of higher dimensional planes. Could it be that science and ancient wisdom are converging? Before Genesis, the universe was in a state of quantum uncertainty, a mysterious realm where the rules of classical physics break down. Quantum mechanics suggests that particles can exist in multiple states simultaneously, and time itself may have had no meaning. One intriguing idea is the quantum vacuum fluctuation theory, which posits that the universe emerged from a sea of energy fluctuations. Tiny ripples in this vacuum could have expanded exponentially, sparking the birth of everything we see today. This concept resonates with ancient ideas of creation emerging from chaos. It's astonishing how the tiniest quantum processes could lead to the birth of stars, planets, and even life itself. The origins of Genesis might be rooted in the unpredictable, mind-bending world of the quantum. Long before science, humans turned to philosophy and mythology to explain creation. From the Norse tales of Ginnungagap, a gaping primordial void, to the Greek idea of chaos birthing the cosmos, these stories offer unique perspectives on the origins of Genesis. What's truly remarkable is how these ancient myths often echo scientific concepts. For instance, the Egyptian god Adam is said to have created himself from a formless, watery abyss, an image not too far removed from modern theories of a primordial soup or cosmic singularity. These myths may not be literal, but they reflect humanity's timeless quest to understand where we come from. They remind us that Genesis, in its oldest form, is not just about science but also about imagination and wonder. After the Big Bang, it took hundreds of millions of years for the first stars to form. But what came before that? The universe was a dense, hot soup of particles and energy, slowly cooling down. Tiny fluctuations in this primordial plasma eventually led to the formation of matter as we know it. These first stars ignited a chain reaction, creating heavier elements through nuclear fusion. Without this process, life itself would not exist, there would be no carbon, oxygen, or nitrogen. This period, often referred to as the cosmic dawn, marks the transition from chaos to order. Understanding how stars and galaxies formed gives us insight into the oldest origins of Genesis. It's a reminder of how interconnected everything is, from the tiniest atom to the vast expanse of the cosmos. Modern advancements in astronomy, physics, and philosophy have brought us closer to understanding the origins of Genesis, but we are still scratching the surface. Space telescopes like the James Webb are peering further back in time than ever before, uncovering galaxies that formed shortly after the Big Bang. Yet, questions remain: was there truly a beginning, or is existence infinite? Can science ever fully unravel the mysteries of creation, or will it always be intertwined with philosophy and spirituality? The origins of Genesis challenge us to think beyond the confines of time and space. It's a humbling reminder that we are part of something far greater than we can comprehend, a story billions of years in the making. One of the most fascinating questions surrounding the origins of Genesis is the birth of time and space itself. According to Einstein's theory of relativity, time and space are interconnected, forming a fabric that can bend, stretch, and warp. Before the Big Bang, there may not have been time as we understand it. Instead, time could have emerged as the universe expanded. This idea reshapes how we think about the concept of beginnings. Was the Big Bang truly the start, or merely a transformation of something pre-existing? Exploring the birth of time and space pushes us to consider what existence really means and how deeply connected we are to the cosmos. The multiverse theory suggests that our universe is just one of countless others, each with its own set of physical laws. This implies that the origins of Genesis might not be a singular event but an ongoing process occurring across infinite dimensions. Some universes may be similar to ours, while others could be wildly different: no stars, no planets, or even no matter at all. This theory forces us to rethink what creation means. Could Genesis be an eternal cycle, with universes constantly being born and reborn? The multiverse concept expands our understanding of reality and opens up mind-boggling possibilities about where we come from and where we might go. Dark matter and dark energy make up about 95% of the universe, yet we know so little about them. These mysterious forces played a crucial role in shaping the cosmos after the Big Bang. Dark matter acted as a scaffolding, helping galaxies form by pulling matter together with its gravitational pull. Dark energy, on the other hand, is causing the universe to expand at an accelerating rate. Understanding these enigmatic substances could unlock deeper insights into the origins of Genesis. They remind us that the universe is far more complex than what we can see or measure. The cosmic microwave background, CMB, is often called the afterglow of the Big Bang. It's a faint radiation that fills the universe, providing a snapshot of what the cosmos looked like 380,000 years after its birth. Studying the CMB has allowed scientists to map the early universe in stunning detail, revealing tiny fluctuations that eventually grew into galaxies. It's like a time machine, letting us peek into the moments following Genesis. This relic of the Big Bang connects us to the earliest chapters of the universe, offering clues about how everything began. Why does the universe seem so perfectly tuned for life? The anthropic principle suggests that the physical laws and constants of our universe are exactly what they need to be for life to exist. If gravity were slightly weaker or stronger, stars couldn't form. If the charge of an electron were different, atoms wouldn't hold together. These fine-tuned conditions lead some to wonder if Genesis was guided by design, chance, or necessity. This principle not only deepens the mystery of creation but also highlights how fragile and unique our existence truly is. In the early universe, only the lightest elements existed: hydrogen, helium, and traces of lithium. These elements formed in the first few minutes after the Big Bang during a process known as Big Bang nucleosynthesis. Over time, these simple atoms combined under immense pressure and heat to create heavier elements within stars. This process, known as stellar nucleosynthesis, laid the foundation for planets, life, and everything we know today. The formation of the first atoms was a pivotal moment in the origins of Genesis, marking the start of chemical complexity. Gravity, the invisible force that holds the universe together, played a vital role in the creation of stars, galaxies, and planets. Without it, matter would have remained scattered, never clumping together to form the structures we see today. This fundamental force is one of the key drivers of cosmic evolution. Gravity's influence stretches back to the earliest moments of the universe, guiding the process of Genesis every step of the way. Understanding gravity's role helps us appreciate the delicate balance that allowed the cosmos to emerge from chaos. Black holes are some of the most mysterious objects in the universe. Surprisingly, they might hold clues about the origins of Genesis. Recent theories suggest that black holes could act as seeds for galaxy formation or even connect to other universes. In the early universe, supermassive black holes formed rapidly, pulling in enormous amounts of matter. Their influence helped shape the galaxies we see today. Could black holes also be tied to the birth of time, space, and matter itself? The connection between black holes and Genesis remains one of the greatest mysteries in science. The universe seems remarkably fine-tuned to support life, with precise physical constants that allow everything from atomic structure to star formation. This raises profound questions. Was this fine-tuning an accident, or does it suggest an underlying purpose? Some scientists argue that multiple universes exist, each with different laws, and we happen to live in one that supports life. Others see this as evidence of intelligent design. Either way, the fine-tuning of the universe adds another layer of wonder to the story of Genesis. Starbursts, periods of intense star formation, were crucial in shaping the early universe. These energetic events created the first heavy elements and filled the cosmos with light. The intense radiation from starbursts helped reionize the universe, lifting it out of the so-called Dark Ages. This marked a turning point in cosmic evolution, leading to the formation of galaxies and planets. After the Big Bang, the universe entered a period known as the Dark Ages, where no light could escape the dense fog of neutral hydrogen gas. However, the formation of the first stars and galaxies brought about a transformative event known as reionization. During this era, the light from newly formed stars and quasars reionized the neutral hydrogen, allowing the universe to become transparent. This phase ended the cosmic dark ages and enabled light to travel freely, illuminating the cosmos. The reionization era was a critical chapter in the origins of Genesis, marking the transition from a dark, featureless universe to one brimming with light and complexity. Galaxies, the vast islands of stars, gas, and dust, are the fundamental building blocks of the universe. But how did they form? The earliest galaxies emerged when gravity caused matter to clump together, forming dense regions that became hotbeds of star formation. Over billions of years, these young galaxies collided and merged, creating the stunning variety of shapes and sizes we see today, from majestic spirals like the Milky Way to elliptical galaxies and irregular ones. The birth and evolution of galaxies reveal how Genesis unfolded on a grand scale, creating the cosmic neighborhoods we now call home. The universe isn't just a random scattering of galaxies, it's organized into a vast structure known as the cosmic web. This intricate network consists of filaments of galaxies and dark matter, connected by gravitational forces. The cosmic web began forming in the early universe, as tiny fluctuations in the density of matter grew over time. These filaments guide the motion of galaxies and shape the large-scale structure of the cosmos. Studying the cosmic web helps scientists understand how Genesis expanded from microscopic quantum fluctuations to the grand cosmic tapestry we observe today. Supernovae, the explosive deaths of massive stars, played a vital role in the origins of Genesis. These powerful explosions scattered heavy elements like carbon, oxygen, and iron into space, elements essential for the formation of planets and life. Supernovae also triggered new waves of star formation by compressing nearby clouds of gas and dust. In this way, they acted as cosmic recyclers, ensuring that the materials for life were spread throughout the galaxy. Without supernovae, the universe would be a very different place, devoid of the building blocks of life. They remind us of the incredible interconnectedness of creation. The formation of solar systems was another crucial step in the story of Genesis. Our own solar system began as a swirling cloud of gas and dust, shaped by gravity into a flat, spinning disk. Over time, the Sun formed at the center, and the remaining material coalesced into planets, moons, and asteroids. This process, known as accretion, created not just the Earth but countless other worlds throughout the universe. Each solar system is unique, with its own potential for harboring life. The birth of solar systems highlights the ongoing nature of Genesis, as new stars and planets continue to form even today. Water, a key ingredient for life, has a cosmic origin story. Most of the universe's water formed in the earliest stars, where hydrogen and oxygen fused together during stellar nucleosynthesis. When these stars died in supernova explosions, water molecules were spread across space, eventually becoming part of planets, comets, and asteroids. This interstellar delivery system brought water to Earth, making life possible. Understanding the origins of water connects us to the stars, showing how Genesis shaped not only the cosmos but also the conditions for life. We are, quite literally, made of stardust. The heavy elements created in stars and spread by supernovae became part of the Earth and eventually formed the building blocks of life. From simple molecules like amino acids to complex organisms, life evolved through processes shaped by the conditions set in motion during Genesis. This connection between the cosmos and biology underscores the unity of all creation. The story of Genesis isn't just about the universe, it's also about us, tracing our origins back to the stars. One of the most surprising discoveries of the 20th century was that the universe is not static, it's expanding. This insight, first revealed by Edwin Hubble, showed that galaxies are moving away from each other, driven by the mysterious force of dark energy. This expansion began with the Big Bang and continues today, reshaping the cosmos over time. The idea of an ever-expanding universe raises profound questions about the future of Genesis. Will the universe expand forever or eventually collapse back on itself? The expanding universe is a testament to the dynamic nature of creation. While we've focused on the origins of Genesis, the story doesn't end there. The universe is constantly evolving, with new stars, planets, and galaxies forming every day. Scientists speculate about the far future of the cosmos, whether it will end in a big freeze, big crunch, or something else entirely. Whatever the outcome, the process of Genesis is ongoing, shaping the universe in ways we are only beginning to understand. Black holes are not just destructive, they play a crucial role in shaping galaxies. Supermassive black holes, often found at the centers of galaxies, emit massive amounts of energy as they consume nearby matter. This energy influences the formation of stars and the distribution of gas within the galaxy. These cosmic giants help regulate galactic growth, preventing runaway star formation by heating and expelling gas. In this way, black holes act as both creators and destroyers, pivotal to the ongoing story of Genesis. Their dual nature highlights the delicate balance between chaos and order in the universe. The origins of Genesis didn't just create stars and planets, it also set the stage for life. Organic molecules, such as amino acids and nucleotides, have been found in interstellar space, on comets, and even on moons like Europa and Titan. These molecules are the precursors to life as we know it. They form through chemical reactions facilitated by cosmic radiation and the energy from stars. The universality of these processes suggests that the building blocks of life could exist throughout the cosmos. This raises exciting possibilities about life beyond Earth, a continuation of Genesis on a cosmic scale. Time is a fundamental element of the Genesis story, shaping the progression of events from the Big Bang to the present day. But what is time? Scientists believe it's a dimension woven into the fabric of space, influenced by gravity and velocity. Einstein's theories of relativity revealed that time is not absolute, it can stretch, contract, and even stop under certain conditions. This means that time itself was born alongside the universe and evolves with it. The nature of time adds another layer of complexity to the Genesis narrative, challenging our perceptions of beginnings and endings. While we often think of Genesis as a single event, the universe operates in cycles of creation and destruction. Stars are born, burn brightly, and die, scattering their elements into space to form new stars and planets. Even galaxies collide and merge, forming entirely new structures. This endless cycle of death and rebirth keeps the cosmos dynamic and ever-changing. The cyclic nature of Genesis shows that creation is not static but a continuous process, driven by the forces of nature and the laws of physics. The very fabric of the universe is thought to have originated from quantum fluctuations, tiny disturbances in the energy of empty space. These minuscule ripples, amplified by cosmic inflation, became the seeds for the galaxies we see today. Quantum physics explains how these fluctuations emerged in a chaotic, high-energy state, eventually giving rise to matter and structure. This connection between the microscopic and the cosmic is one of the most profound aspects of Genesis. It reminds us that the smallest forces can have the most monumental effects, shaping the entire universe. In the first fraction of a second after the Big Bang, the universe underwent a period of rapid expansion known as cosmic inflation. During this time, it grew exponentially, smoothing out irregularities and creating the conditions for galaxies to form. Cosmic inflation explains why the universe appears uniform on a large scale, despite its chaotic beginnings. Without this critical phase, the cosmos might never have developed the structure we see today. Inflation is a cornerstone of modern cosmology, offering insights into the earliest moments of Genesis. 31. The role of neutrinos in the early universe. Neutrinos, often called ghost particles, are among the most abundant particles in the universe, yet they rarely interact with matter. In the early universe, neutrinos played a key role in its evolution by influencing the distribution of matter and energy. These elusive particles carry information about the conditions of the universe just moments after the Big Bang. Studying them allows scientists to reconstruct the earliest chapters of Genesis, providing a clearer picture of how the cosmos unfolded. Neutrinos are a subtle but vital piece of the creation puzzle. 32. The mystery of antimatter. One of the biggest mysteries of Genesis is the imbalance between matter and antimatter. According to theory, the Big Bang should have produced equal amounts of both. Yet, our universe is dominated by matter, with antimatter being exceedingly rare. Scientists believe this asymmetry, known as baryon asymmetry, holds the key to understanding why the universe exists in its current form. Experiments at facilities like CERN are probing this mystery, hoping to uncover the processes that tip the scales in favor of matter. The antimatter puzzle reminds us that Genesis is still filled with unanswered questions.
Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.